All right, everyone. I hope this discussion section problem set is going well. I do know that some of these questions can seem a little bit overwhelming when you first look at it, so I wanted to show you how I attack a question like number 7, which is about gasoline prices and has a lot of movements, a lot of pieces of information that sometimes cause people to get a little bit confused. So let me show you how I would answer this question. So the question starts off by saying we've got a couple pieces of information about gas prices. So in February 2016, we had an average gas price of $1.72 across the country. All right, this increased to $2.40 by June 2016. Right, that's only 4 months, and we've got a 40% increase in gas prices. So, how could this have happened? Why is this actually occurring? An important piece of information that you're given at the end of the question is that we're going to assume that between February and June 2016, supply of gasoline was unchanged. Okay, so this is actually all the information we need to be able to figure out what happened in the gasoline market in this 4-month period in 2016. So the first thing we're going to do is we're actually just going to center ourselves in February 2016 and say the demand for gasoline in February 2016, all right, look like that. And then we've got the supply curve. Right, it looks like this. Now, I'm not drawing these in any specific way. I'm just saying that our supply was the same in February versus June. It's just an upward sloping supply curve. Our demand in February 2016 intersects this supply curve right here at $1.72. Okay, so I'm not going to put a particular quantity on here. I'm just going to call it quantity in February 2016, and we're going to say this is equilibrium in February 2016. Okay, so then we're told that prices went up to from $1.72 to $2.40, but supply didn't move. So that means that our new equilibrium in June 2016 has got to be on the same supply curve as what it was in February. So a way to show that is that we've got a $2.40 price level. That's going to intersect our supply curve right there. And this will be our equilibrium in June, equilibrium quantity in June 2016. So in order for that to be our equilibrium point, it must mean that we've got a new demand curve. Where is that new demand curve? Well, the way that I've drawn this, it's not necessarily to scale, but it has to go through the demand curve has to go through that point on supply at $2.40. So our demand in June 2016 is right there. Okay, so we would say that our demand for gasoline increased between February and June. So the only way that we could have prices go up between February and June and have supply not change is if demand increased. Okay, so let's think about why would demand increase between February and June 2016? Well, think about your own behaviors. What's going on in February? In most parts of the country, we've got maybe bad weather, all right, snow, ice storms, things like that. All right, we're in the middle of a school year, all right, and it's really not vacation time. All right, not vacation time. So these are all things that are happening in February. When June hits, weather gets good, all right? So I'm going to go ahead and X that out here, cross that out, all right, when we're thinking about what happens in June. So we go from bad weather to good weather, right? We're out of school in June, all right? This is a heavy vacation time, right? Lots of travel, all right? And these are all happening in June. All of these things are going to lead to an increase in travel and increase in the demand for gasoline. All right, so now we're going to go, we're going to go from an equilibrium in February 2016 at 172, and that's going to increase to an equilibrium of June 2016 when demand increases. Okay, so that really kind of covers parts A and to some degree B, right? We can think about what happens every year between February and June, right, that's going to increase the demand for gasoline. Okay, so then in part C, it says, all right, during the week of June 30th, 2014, gas prices were a lot higher than in 2016. we're told some other pieces of information, specifically that the demand for gasoline in 2014 and 2016 are going to be assumed to be the same. So how do we deal with this question? Well, instead of messing your original graph up, why don't we go to a new graph? Why don't we say, we're looking now at gas prices in 2016 versus 2014. So again, in 2014 they were $3.70. They decreased to $2.40 in 2016. That important piece of information is that we're going to assume that demand is the same between June 2014 and June 2016. Okay, so what happened? What could have potentially caused this? So I'm going to work backwards a little bit, and I'm going to start ourselves where we ended the last question, right? We've got a supply curve, all right, and that supply curve is associated with, get that on here, the supply curve is associated with 2016, just like it was last part of the question. And then we've got a demand curve here. Where did we end? Well, we've got our demand curve in 2016 right here, and our equilibrium point is telling us that the price of gas is $2.40, and we've got a quantity, we'll just say quantity in 2016. This will be our equilibrium in 2016. We'll assume it's June 2016. Okay, if demand is the same between 2016 and 2014, because we're just looking at June, right, we've got a higher price, $3.70, but that $3.70 price is going to be the equilibrium on that original demand curve. So this demand curve is also associated with 2014. So that must mean that that supply curve had to intersect $3.70 along that original demand curve. So supply then in 2014 had to have been right there. We'd have to have an equilibrium in 2014 right there, and a quantity right there. So the way that we can tell a story about this is that in 2014, our equilibrium was out here at $3.70. Between 2014 and 2016, the supply of gas must have increased or shifted to the right. Okay, so we go from 2014 to 2016. When this happens, this leads to a decrease in prices and an increase in the quantity bought and sold. Is this reasonable? Is this a reasonable thing to expect, or when we look back in time, did this actually happen? Well, during this time, there was a big increase in U.S. oil production. This big increase in U.S. oil production is going to increase that supply curve or shift it to the right, and that would explain the reduction in prices of gasoline that we saw between 2014 and 2016. So what do we get out of this question? It's a long question, it's a tough question, it's a complex question, but take each part just as it is. Don't try to overwhelm yourself with all these things going on at one time, right? We can just say we're given a piece of information initially about gas prices. We can talk about how it's different. The demand for gas is different between February and June. But if we look over a longer time horizon, maybe if we look at June 2014 versus June 2016, people might not be, consumers might not be reacting very different between those two time periods, but we've got this big change in supply that's going to lead to a difference in price over time. So again, long question, but I think if you dig into this and work on questions like this, you're only going to get better at these types of questions. So, all right, hope that helps, and we'll see you guys next time.